Hello everyone, welcome to my channel. In this video, I will explain about learning with trees, decision trees. So this concept belongs to machine learning. This notes is enough to write in the examination. So first let us see the definition. A decision tree is a supervised machine learning algorithm used for classification and regression tasks. Okay, so what is the main purpose of this decision tree? It is a supervised machine learning algorithm. So what is the meaning of supervised learning algorithm? It is going to use the labeled data. So the main purpose of this decision tree is we are going to use for classification as well as regression tasks. So remember all of you, a decision tree is a supervised learning algorithm. Moreover, it is used for classification and regression tasks. So what is the meaning of classification? We are going to classify the data whether it is examples are something like male or female, 0 or 1, true or false. Regression. So what is the meaning of regression? Regression nothing but we are going to predict the data. Something like whether in the IPL match in the RCB is going to win or not. So this is called as a regression. Regression nothing but prediction. Okay, so classification and regression, one of the major applications of this decision trees. Now you observe one diagram which belongs to decision tree. So remember all of you, top of the node is always we can say it is called as root node. So this node is called as root node, and these two nodes are called as internal nodes, and last nodes which does not have any left and right side. So these are called as leaf nodes. You observe there is no left and right here. There is no left and right here. There is no left and right. There is no left and right. So these are called as leaf nodes. Okay. So this is called as a decision tree. So actually what is the purpose of this decision tree? It is used for classification and regression. Okay. So let us move forward. So let us see one of the example regarding this decision tree. You observe on the screen. So here the top of the node is called as root. Here root nothing but weather. I am going to draw the decision tree for whether a person is going for walk or not. Okay, when the person is going to walk, you observe when the weather is sunny. Okay, when the weather is sunny, the temperature is cool, he is going to walk. When the temperature is sunny, when the weather is sunny, temperature is hot, he is going to no walk. So this is called as a decision tree. So I am going to take the decision whether a person is going to walk or not. So it depends upon sunny or rainy. If at all there is something called as rainy, you should be stay home. Okay, so this is called as a decision tree. Let us move forward. Now you observe one of the most important slide. So this is called as a types of decision trees. So remember there are completely three types are there in the decision trees. So first one is called as ID3, and the second one is called as C4.5, and third one is called as a cart. Okay, so there are completely three types of decision trees are there. So we'll see one by one now. So what is the meaning of ID3? So ID3 nothing but ID3 algorithm is used to build a decision tree for classification problems by selecting the attributes using entropy and information gain. Okay, so what is the purpose of ID3? ID3 is to build a decision tree. So main purpose is we are going to build the decision tree for classification problems. Okay, by setting the attributes entropy and information gain. So we'll discuss what is this entropy and information gain. Okay, so we'll see the examples related to this ID3. Now you observe what is the meaning of entropy. So entropy nothing but here you can see on the screen. Entropy is it is a measure of impurity in data. So remember the keyword is entropy for keyword for entropy is impurity. Okay, so when I say purity, the data is correct. When I say impurity, the data is going to be wrong. So when the data is purity, what is going to be happen? So what is the meaning of entropy? It is a measure of impurity in data. So how much percentage the purity of the data is there. Okay, now we'll see what is the meaning of entropy in information theory. So entropy measures the amount of impurity in a set of features. So example, if all pass, so all the students are pass, you are going to say entropy is 0. Suppose if the combination of pass fail, so what is going to be happen? It is mixed. So we are going to have some ambiguity. Hence we can say this is called as high entropy. Okay, entropy 0 means this is a positive where all the students are pass. But when I say it is a combination of pass and fail, what is going to be happen? There is a high entropy. So the entropy of the set of probabilities, so that is pi, is entropy of P is equal to, you observe the formula sigma minus Pi log to Pi. So this is a formula to calculate the entropy. So what is the meaning of Pi? Pi nothing but probability of each class used to calculate impurity. Okay, so logarithm is based to, we encode everything using binary digits. So we are going to encode by using binary digits. So 0 and 1 are called as binary bits. So this is called as what we say entropy. So please remember all of you, impurity nothing but amount of impurity, we can say this is called as entropy. So how much purity is there? We are going to say that is called as entropy. Suppose if all the students are pass, the entropy is equal to 0 because there is no confusion. But if the data is mixed with pass fail, this is called as a high entropy. So let us see one more example for more clarification. You can observe on the screen. So there is a table is there. This table is having 3 attributes. So first attribute is height, and second attribute is weight, and third attribute is class. Okay, now what is the meaning of this table? I have given heights, I have given weights, so the class is male or female. If the height is 170, weight is 75, I am going to say, let us assume the person is female. So when the height is 170 centimeters and weight is 90 kgs, I am going to say the person is male. So similarly, all the details are there in the form of table. Now I am going to draw a decision tree for this. So if you observe here, there are 2 categories. One is male and second one is female. Height is greater than 180. You observe when the height is 180. So when the height is greater than 180, this statement is called as male. So okay, so height is greater than 180. Yes, this is called as male. Okay, if no, so you observe here one more category is called as 170. He is also male, but here the parameter height is not enough because we cannot justice this all males. So I chosen a greater than 180 is as male. Now what is going to be happen? I went to this weight. So you observe the male weight is 90 and all other are less than. So what is going to be happen? I am going to say weight is greater than 80. Yes, I am going to say male. Otherwise she is female. So this type is called as a decision tree. Okay. Now you observe how to draw this decision tree. So if here the data is greater than 180, I am going, so let us assume, so in the first one the parameter is height. Okay, when I say the splitting parameter is height, what is going to be happen? We are going to divide data into 2 types. So first one is a left tree and right side is a right tree. So when the data is greater than 180, So 180 means you are going to get 185, 85 male. In the left side, we are going to get all the data. 170, you observe 170, 170, 155, 175. Okay. So now I am going to say greater than 80 is called as male. So in this, the parameter is height, but in this the parameter is weight, because after completion of height we received one diagram, but it does not cover all. Okay, so to cover all the things we are going to use here weight as parameter. So when the weight is parameter, how when the weight is 90, I am going to say the person is male. When the weight is less than 80, so all are females. So this kind of diagram is called as decision tree. Okay, now one of the most important concept here, each level which attribute is selected as splitting attribute. Okay, if you observe the splitting attribute is height here, if you observe in this the splitting attribute is weight, but the question is at each level which attribute is selected as splitting attribute. So if you go for random selection, it is not a good idea. Okay, because it may give something called as a bad results with low accuracy. So in order to split an attribute, we are going to use something called as two factors. First one is called as information gain, and second one is called as Gini index. Okay, so in this we'll talk about information gain. So you observe what is the meaning of information gain. So before going to discuss about the entropy, so actually in this entropy will play a major role. So before going to discuss about this entropy, so we'll focus on, so before going to discuss about this entropy, we'll focus on information gain. Okay, so it is a measure of impurity in the data set. It is a subset of all samples in the same class. Okay, so now you observe what is the meaning of information gain. It is nothing but measurement of impurity. So we are going to measure whether the data is pure or not. If it is pure, it is going to display the value as 0, otherwise it will give the value as 1. So in the information gain, we are going to measure the impurity in data set. It is a subset of all samples in the same class. You observe there are 3 diagrams are there. First one is called as it contain all values are females. So there is no confusion. Hence we can say this is called as pure. All males, I can say this is called as pure. But it is a combination of male and female. I can say this is called as impure. Okay. If a node is pure, the entropy is 0. If a node is impure, the entropy is 1. So in this value, the first one is this is 0, this is 0, but this is called as 1 because the data could be impurity. Now this is called as a graph which is explained about the entropy. You observe here the values are 0, 1 and 0.1 in between 0 to 1. So here the entropy measures this graph where, so we are going to draw the line from here to here. So this is called as proportion of samples. Okay, now we'll see more examples on here. So entropy, 2 class data set 0 to 1. Okay, so let us say there are 2 class data set. In the above we have taken 2 classes, that is male or female. So 2 class data set 0 to 1. So if it contains n class, the data could be 0 to log n. So if the n is here, number of classes. So how to find out this entropy? Entropy of S is equal to sigma I is equal to 0, 1 to C minus Pi log to Pi. So what is S? S is a subset of data set. Here this S. Okay, so this S is called as subset of data set, and C. So this C is called as this C. C is called as number of class labels and portion of ith class. Okay, now let us take the above example, so male, female, female, female. So this example come from here, this box. Now we are going to find out the values here. So we are going to find out the entropy. Let us see how to find the value of entropy. Now you observe here, we are going to find out the entropy value. The formula could be sigma I is equal to 1 to C minus Pi log to Pi. So here we are going to find out the value of entropy. If you observe here, first we will check, we are going to find the value of here entropy. So if you see here, there are one male is there, there are 3 females is there. Okay, so when you say sigma I is equal to 1 to C P of I P log to Pi, so what you have to do, how many males are there? 1 male. How many females are there? 3 females. Okay, so how could this 4 come? Because of number of samples. So the number of samples are 4. 1, 2, 3, 4. So this is called as minus 1 by 4 log to 1 by 4 minus 3 by 4 log to 3 by 4. The answer could be here 0.81125. So this is the way to calculate the entropy. Now we talk about the information gain. So what is the meaning of information gain? The measure of reduction in entropy. Okay, so it is used to select the best splitting attribute when constructing a decision tree. So what is going to be happened in the information gain? So we are going to measure the reduction in entropy. Okay, so in this maximum entropy reduced, more information. Again, you observe in this we have taken one table. So let us say the table is male, female, female, male, female, and male, 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 female, female, and female, female, male, male. So total the total number of values are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So completely in this we have the total data items are 14. Now what I am going to do, I am going to split this data based on height. Okay, so when I say, let us assume, when I say based on height, I received in the left side these number of values, I received in the right side these number of values. So this is called as left side data, this is called as right side data. Now you observe the above data is not best split because the nodes after split, the child contain equal number of female and male. Now you observe in this the total number of males are 1, 2, 3, 4, and similarly females also 4. So when the majority is not there, when it contains equal number of productions or values, we cannot say which is a splitting variable, splitting value. Hence it contains equal number of males and females. So we cannot say child node is male or female. Hence we can say this is not correct or not suitable split. Okay, so this is about the when we talk about the height. But when we talk about the weight, let us assume the splitting could be something like in the left side we have 5 number of males, in the right side we have 2 number of males and 7 number of females. Now we can say this is called as a perfect split because I can observe here the majority is 5 males and in this the majority is 7 females. Okay, we cannot accept only when both are equal. Now you observe how to calculate the information gain. So information gain is entropy of S is minus sigma of mod SV by mod S into entropy of SV. Okay, now you observe here in this we say entropy of 5 minus. So when you find out the SV, okay, so what is this SV? SV nothing but subset. Okay, it is a subset after first split, after this split. Okay, so after this split, the first child node we have in this 5 males. So total how many males are there? 5 males. So after completion of this one splitting, so we have first 5 males. That's why we have taken 5 males. Okay, divided by the total. So in this we have the total is 14. So this total we have written, that is called as minus 5 by 14 into entropy of. So let us say this is called as S1, this is called as S2. So let us say there are two values, S1 and S2. Okay, now you need to find out the value of entropy of S1, entropy of minus. Now when it comes to second one, what we have to do, in the first one we have taken this first night, this we have taken 5 males, but in the second one what you have to do, you need to sum this one. So see, 7 plus 2 is 9, so this could be 9 by 14. Okay, so this is called as 5 by 14 and second one is called as a 9 by 14 because we are going to take the summation. And now what is going to be happen, we need to substitute all the values of this entropy. Already we discussed it in the previous. So what is going to be happen, after completion of all calculations, the feature common, okay, the feature with maximum information gain will be selected as the best splitting attribute. So we are going to find out all the information gain values. So what is the best split? When you get the maximum, okay, so you need to find out all the values. You need to select only the maximum information gain. So this is about the information gain. So second one is the C4.5 algorithm. So till now we talk about only ID3. Now we talk about the C4.5 algorithm. So C4.5 algorithm is the advanced version of ID3. Okay. So what is the limitations then? ID3 has some limitations. It cannot handle continuous values and it cannot manage missing values. If at all any value is there, if at all any value missed, ID3 cannot manage, always it won't accept and it cannot handle continuous values. So C4.5 algorithm uses gain ratio instead of information gain to choose the best attribute. Okay, so in the previous we talked about the information gain, but in this we discussed about the gain ratio. It handles both categorical and continuous data. So category means again male, female, 0 or 1 and true or false. So it can manage missing values in data sets. Let us see the algorithm. So first what we have to do, you need to select the root node and calculate the information gain. So how to calculate information gain? That is equal to entropy of parent minus weighted entropy of children. Okay, now calculate the split information. So how to calculate the split information? Minus sigma equal to 1 to n di by d mod log to mod di by mod d. So this is called as we are going to calculate the split information. So why we need to calculate this split information gain? Because we need to calculate the gain ratio. So already we discussed na? In the previous one we talk about the information gain. In this we will discuss about the concept called as gain ratio. So how to find out gain ratio? This is called as information gain and splitting information. So what you have to do? Finally you need to select the choose best attribute in order to split the table. And sixth one, split the database also, data set, repeat recursively until you get the best value. So finally pruning. So pruning means cutting. Cutting means we are going to remove the unnecessary values. So this is called what we say C4.5. So final one is called as a cart. So what is the meaning of cart? Cart nothing but classification and regression tree. So what is the meaning of cart? Cart is used for both classification and regression. Yes. Then what is the meaning of classification? It is going to predict the categories. Regression means it will predict the numerical values. So you observe this is called as a decision tree. So first one is a root node and second one is called as internal nodes and the last nodes are called as a leaf nodes and this is called also again internal node. Now what is the basic algorithm related to this cart? So what is going to be happened? First we need to evaluate the best split. Second one, we need to select the optimal split. And third step, we'll have create binary child nodes. And fourth one, repeated recursively. So these are the major steps in cart. So first we go with the best split. Okay, so you need to evaluate the best split. Second one is the optimal split. So select the optimal split means which is the minimum value. So third one is the create binary child nodes. Last one is the repeat recursively. So recursively means you need to do again and again until you get the best value or correct value. Now till now we discussed about the three different algorithms in decision trees. Now we'll see what is the difference between this ID3, C4.5 and CART. You observe on the screen. So what is the meaning of ID3? ID3 full form is actually iterative dichotomizer 3. So what is the full this C4.5? It is the successor of ID3. What is the full form of CART? Classification and regression tree. So in this ID3 splitting criteria based on information gain, already we discussed. In the C4.5 the information is based on gain ratio, but when it comes to CART the information is based on variance reduction. Okay, so remember ID3 won't accept, not handled missing values. So when it comes to C4.5 it handles missing value, it also handles missing value. Now in the ID3 no pruning concept is there, but in the C4.5 we have post pruning concept is there. In the CART we have cost complexity pruning is there. Now the last one is when the complex belongs to ID3, this is simple, but when it comes to this C4.5 it is moderate, and last one is called as a CART, it is very powerful. So please remember, out of ID3, C4.5, CART is one of the most important and powerful mechanism. This is all about the decision tree algorithms. Okay, so thank you for watching this video. Please subscribe my channel. Thank you one and all.